So this example is the Dunedin City Council's pipeline that comes through from Deep Stream, I want to say. It could be Deep Creek, whichever is the more important one of those two. It comes in along this roadway and comes to the southern reservoir, the DCC southern reservoir. So we went out and flew the site to get ourselves this kind of coverage. So this is the digital surface model that is created from the photography. Probably more interesting than that is the orthomosaic. So this is an ortho-corrected aerial image that's produced from the overlapping photography to create a true model, which is projected vertically. So if I zoom in on this a little bit, we can start to see the original concern. The reason we were asked to come and visit this site was because of slip. The slip had come and undermined part of the main pipeline. This is a concrete socket and spigot pipeline. As I zoom in, these are a good example of how good the models can get to be. So we had a very, very temporary measure of strapping back this pipeline to see if we could fix it, at least make it safe in the short term. So the ortho image is good. As well as that, we can use this as a communication tool to talk to the client about what our concerns are. They asked us to pick up some yellow markers that they had painted on the ground so that they could orientate the pipeline in relation to the property boundaries. So they are kind of property boundary pegs. You can see they're quite visible on the model. So we've been through and we have looked at some of the concerns that we have that only became available to see once we brought this model back into the office and run it. This is a good example. This crack was not visible from the road, but if I flash the orientations on and off, you can see that, well, it's a pretty healthy crack. It's opened by as much as 300 mils. Just wasn't visible from the main access track, but when you start looking for it, you can't unsee it. In fact, if I flash this backwards and forwards, hopefully you'll be able to see what we're seeing when we're doing the assessment. So this particular pipeline has a number of risks associated with it that we've identified from the aerial drone model. This has been pretty useful from just looking at it from a plan perspective. You can see here is the extent of the previous slip that we've identified on previous work. This particular site is actually part of a much, much larger landslide complex that we're well aware of. So this is actually, as much as this is a creek here, it's not actually just a creek, it's a margin of the greater landslide which actually comes around and comes back down through the forested area. You can see that the forest has now been cleared on our imagery, but they do have a couple of areas that are quite close to the undermining the pipe. So they have a resilience issue in terms of this particular pipeline. As well as that, if you want, from the photogrammetry, we get this kind of a 3D model. We used to use Skycatch. We've recently changed to using Pix4D. So the model is produced by artificial intelligence recognizing multiple points in multiple photographs. And the result is that not only do you get a top-down map, but you get something like this, which is, hopefully I can pan around here, and you can see this is kind of like Google Earth on steroids, is what I like to call it. And as we zoom in on the map in certain parts, you can see that the resolution of the model can be really very, very good as well. So you end up with, basically a full point cloud or a 3D surface which can be exported into AutoCAD and used directly for design purposes. You can start cutting cross sections through this. You can do essentially exactly the same things as you could do with a bunch of arbitrary